Welcome to our next short series. This one's going to be on segment turning, but open segment. And I think I lied to you in the last video. I said this would be a two-part series, but the more I've thought about it, there's so much information here that I want to share that I think we'll make this into 3 parts. And the first part is I want to talk to you about what open segment is and how it's different. And then show you one technique for doing it, the classic, the way it was originally developed. And in part 2, we'll go into a different technique, which you may find better or less better, kind of depending on you. And in the third one, I'm going to look at some new techniques, and then I'm going to actually show you turning an open segment vessel. There's probably a few things I do differently with open segment than I might do with a regular segment piece. So, what is open segment? Well, here's a vessel that I've turned some time ago, and it's a mixture of ring segmented turning, which is what we did originally, which is gluing a bunch of pieces together, making a ring, stacking them up, and making a vessel. And open segment, where the pieces don't touch each other, which requires a whole new set of techniques for mounting and securing the pieces. Let's talk a little bit about how open segment differs from traditional ones. Well, first of all, let me show you a slide. On this slide, you see how traditional segmented turning is done. The pieces are glued together, we figure out the diameter we want to be, calculate the circumference, divide it by the number of pieces, and we get these calculations, and we come up with a segment edge length, and we make the rings. Well, that's fine and dandy, we talked about that before. But in open segment, I'll do the same thing, except instead of coming up with a segment edge length of a certain dimension, this next slide shows you that I actually am going to reduce that segment edge length by some specific percentage. And if I reduce that by some specific percentage, I'm going to reduce the cut angle by that same percentage so that the optics look right when you put the pieces together. So technically, that's the only difference. I've just reduced the segment edge length by a percentage, and I've reduced the cut angle by a percentage. But now I've got this piece standing out there and no way to hold it in place unless I can find a way of indexing each of those pieces around that circle. Well, this technique is something that is relatively new to segmented turning. In 1999, Bill Smith did a demonstration at the Tacoma AEW Symposium for the first time after having seen this technique done in Japan. In 2002, he wrote the one book that got us all started on that. And in this book is the basics of everything I'm going to be covering in today's presentation. Indexing, Bill Smith actually produced a series of graphs that you can download or copy from the book, which shows you all various different indexing marks. Well, that's not the way we do it anymore. There's a bunch of companies that have come out and made indexing plates. And I'm going to show you some of the commercial ones. This one I use a lot, and you'll see that in part 2 of this series being used. This is made by a company called Iron Fire LLC. All these references are at the end. And it's fairly inexpensive, but it shows 3 different sets of open segments. For instance, the one I've got marked off here with little circles and squares is 96 segments. So every 4th one is the 24th segment. So I use that a bunch. Here's the one you'll see in today's video segment from turning. This is made by a company called Alisan Engineering, and they make it in this size, and they make a smaller version for the mini lathes. All these come with different hole sizes to fit your lathe, whether it's a 1x8 or 1 1/4 by 8. This one actually comes with a little bar. It's got some rare earth magnets on it that sticks to your lathe. You'll see this in a few minutes. And then this pin will engage these holes. And that's how we move around. I did a piece, which I will show you in a few minutes, of 24 segments. And I needed to have 48 holes. Every other hole for one row, and the next row is offset by 1. So I needed another row of holes, and the holes are there. There's another one that's come out on the market which I'm also using. This is from a company called Chefware Kits. And it has, 6 different rolls on it. This is steel. This is substantially heavy. And it's steel for sure. It sticks to anything. But I've also marked off the ones I wanted to use. Here is every 24th hole. And in between I put a smaller mark, which is every 24th hole offset by exactly half that amount. Well, you can do that. I also made my own. Let me reach out of the screen here for a second. I had some of my friends who have some laser cutting equipment. One of my friends made me this one, which has 3 rolls. The outside one is 360 holes. In other words, every degree in a circle I can accommodate. That was nice. One of my other students, Manoj Gupta, made me this, which he took a piece of plastic and put 3 rows on it. That was also neat. These I've made myself. I took a piece of plastic, put it on the lathe, turned it around, drilled the hole, and I have some machine tool equipment at home, so I was able to put this on a rotary table and index around and drill the holes. Index and drill, index and drill. And I've done a number of these of different sizes and different shapes, even ones that have an uneven number of holes for special projects. Anyway, you need an indexing plate. You can actually even go and take a saw blade, 48 tooth saw blade, put a 1-inch hole in it. In between each one of those teeth in that gullet, there's your 48 position indexing if you want to do that. Lots of ways, but you do have to have indexing. And in today's video segment, which I'm going to run in just a moment, I'm going to show you how this is done by Bill Smith's classic way on the lathe. So you're going to see me set up an indexing plate on the headstock. You'll see me mount this device so that I can engage the right holes. And you'll see me set up, and I'll talk about this a little bit more in a second. You'll see me set this device up, which allows me to position each segment right at the center of rotation and of a specific distance from the center of the rotation. So let's take a look at building an open segment vessel. We'll start off cutting the pieces. Now we don't need the fancy Sag-Easy sleds because the segments never touch each other. Perfection in the angle is not necessary. So you'll see me using a standard miter sled in cutting the pieces. And then you watch me installing these segments. There's a couple places in there you'll see me take live time going from one segment to the next. I wanted you to see how many seconds, how much time it lapses between when I put the first one on and when I put the next one on to allow the glue sufficiently to tack for me to move forward. So let's take a quick look at that through the assembly of the top and the bottom of a vessel. And then we'll come back and talk about these fixtures a little bit more. Well, here's the piece that I just showed you the assembly of. I turned it off camera in two parts and glued the two halves together. You didn't see that, but in the third segment of this three-part series, I will actually show you turning one of these open segment vessels. It's not a lot different than turning any other device, but because of these holes and the opportunity to catch square corners coming around on the inside or outside, I do a few things slightly differently, and I'll let you see that in part 3. Keep you coming back. So the key here is installing these segments carefully. And I use this fixture. This was custom made for my particular lathe at home. The distance from here, this fits right in the slot of my miter slot on my particular lathe. From this distance here to the top of this bar is exactly to the center of rotation on my lathe. Now, if your lathe says it's a 20-inch lathe, as 2 or 3 of our lathes here at school are, measure it anyway, because these 20-inch lathes behind me are actually 20 1/4 inches to the center rotation. So you got to be precise. This bar, I have a tape on it so that I can measure the offset from the center. If I'm going to make a 10-inch ring, 10-inch open segment ring, then I need to install this piece 5 inches from the center. So I need not to know the diameter of each layer, but I need to know the radius of each layer. So most of the commercial software will help you part of the way through, but it doesn't give you the last piece of information, radii. So on many of the various companies that sell these plates, they also provide you with tables like that, which just give you radii for different numbers of segments and different diameters. And most of the people who sell these commercial plates people will have these tables in their manuals or able to be downloaded from their website. So, you also saw me using a little piece of metal here, which is nothing special other than it gave me a chance to be able to press that segment in against the assembly and hold it for a few seconds. You could have used anything, a piece of wood. This was at hand, and the fact that it has been ground to a point and it's a certain diameter of high-speed steel has got nothing to do with it at all. It was just convenient, and I could push that piece down to be sure it's registering very, very well. I did not pre-sand all the segments to take the burrs off. I sanded them one at a time. It slowed me down while I did the assembly. And then I took a piece of 100 grit sandpaper and sanded one face again to be sure it's absolutely dead flat, and applied the glue. You also saw me using some pipe cleaners, which I had soaking in a can of water. I wring the water off of it as best I can, and then run it down between the segments after they have tacked on there to get off the excess glue. That glue will turn clear over time, but a glob of glue in that little window that you look through is not attractive. So I clean them off as I go. So sanding, sanding, installing, degluing is a process that's repeated for every single segment. I timed it, and you probably can too. If you watch that video, you go back and play that part over again. But you'll see that's almost 45 to 50 seconds per segment. And that means to go 24 segments around, you can kind of figure there's a half an hour's worth of work in putting each ring in. So there's a tediousness to doing this, but it's also a lot of fun to be able to sit down and install these pieces. I built the bottom half on a solid piece. I had a segmented ring glued onto a separate faceplate, and I built the top half down. Same as we've done on any other vessel. So, this is part one of open segment construction. In part two, I'm going to show you how to do these same operations off the lathe. Each of these methods have advantages and disadvantages. The advantages of this particular one, while it seems slow, is I can sand and true up each level at the end of the glue up because it's already concentric and already on the lathe. On the next method, being off the lathe, I've kept my equipment free. I can work a little bit faster because gravity is my friend and not my enemy. But I then have to take it to the lathe, mount it to true up each layer. So this is the Bill Smith method, referred to in his book on segmented turning, segmented wood turning. Also in my book, I refer to these same techniques. There's a chapter in here, chapter number 6, which takes you through the same process and talks about the same fixtures and jigs. So the next part, we'll do it off the lathe. Come back and see me for part 2.